Hello, this is Peter from Cyberstrak. With this video I want to give you a short introduction of the Cyberstrak match and blend commands. To explain the workflow of the commands in principle, I load here a very simple example part. Let's open the match command. We want to match the surface on the right to the surface on the left. After selecting the edge to match in the reference edge, we activate the embedded position transition analysis. After pressing apply, the edge of the right surface is being moved to the left surface. But when looking to the CV distribution, we see that just the edge CVs have been modified, leading to a pretty bad CV distribution. To get a better one, we can activate the blend option. So the CV distribution gets much more equally distributed now. When we check the position transition, we see that it did not go to 0 yet. This comes from the different degree and number of spans in both surfaces. We can switch the display of the spans on and off in the dock bar. While the right surface is a single span surface, the left has 3 NURB spans. To get a better matching quality, we have to activate the option Adapt Degree Spans. In this case, the right surface is modified in a way that it takes over the geometric properties from the reference surface on the corresponding edge. So now we get a position deviation of 0. Then we repeat this with the higher quality match options, tangency and curvature. We activate also here the embedded analysis functionality to control it. In the dock bar we can also activate a zebra option for the selected surfaces. Playing with the tangent curvature options, we see how they influence the zebra stripes. Depending on the match options, we can also dynamically play with the CV rows in parallel to the matched edge. We can modify the second and third row from the edge. Moving the rows will maintain the transition quality. Like in any Cyberstrak dialog, you can activate a context-sensitive online help. It explains the options and provides some examples. Now we go for the blend command. We use the same simple example as before. We have to select the edges on both surfaces we want to connect by a new blend surface. We find for both edges options similar to the matching command. And also here we have the same embedded analysis functions. We can also play with the second and third CV row in parallel to the selected surface edges. In addition, there are so-called blend factors for both edges. You can have different factors for tangency and curvature. Factor 1 gives you the natural CV distribution on the blend surface with equally distributed CVs. Increasing, decreasing multiplies the given factors to the average CV length. If you specify the same factors to the left and right, you will get a quite symmetrical blend surface. Pressing the arrows will change the surfaces immediately. When you edit the numbers, you will need to press apply first. Changing the rows dynamically will also update the numerical factors. Also, undo redo will show you the factors used in each modeling step. Online help is of course also available. At the end, I want to show you a combination together with some other commands. Here we will use also the smooth command. We see here a pretty bad CV distribution. With the CS smooth command we can try to fix it. Pressing just apply will already improve it. But in this case also the surface edges are changed. If we don't want that, we can lock the surface corners and edges. Now only inner CVs are modified. Now let's match the right small surface to the left. If both edges are close to each other, the command will select the reference edge automatically. At the end, we want to fill the remaining gap with a blend surface. Here it is the right moment to show you the usage of an additional analysis function in parallel to the blend command, the dynamic section. Just starting it will create a set section as a clipping plane across the whole geometry on the screen. In your case, it makes more sense to switch to an X section. If we activate also the section option in the command, it will calculate a curved section on the current plane. With the plane handle, we can move the section in plane normal direction. To check the blend match quality, we can add a curvature graph on top of the section curve. With some options, for example automatic scale or invert, we can influence the appearance further. We can also increase the density of the calculated section. Now we can move the plane handle with active curvature graph. That's it for today. Thank you for watching and talk to you again later.